This is problem 55 on page 546, and this will probably begin to ruin your taste for trigonometry. It's kind of a pretty complex problem, and in fact you can see that they've devoted problems 53 through 56 to this fairly complex figure where you've got a triangle, an inscribed circle, which as far as I can tell has very little to do with anything. The angles are A, B, and C. The sides are A, B, and C. And there are radii drawn from this circle, which is at the point, which is inscribed at a point in such a way that these dotted lines which bisect angles A, B, and C all meet. And then these radii are drawn normals to each of the sides and meet at points D, E, F. Okay. So one more time. Here's a triangle P, Q, R. Circle inside of it. Angles A, B, and C. Bisectors of each of the angles. They all meet at the center of the circle, which I'm just going to take on faith. And then the radius or radii of the circle are drawn out normal to each one of the sides. The sides have a length A, B, C. And oh, by the way, there's another parameter, S, which is the perimeter of the circle, A plus B plus C, lengths of all the sides, divided by 2. Okay, given that, got to understand the question before you can solve the problem. The problem here, at least in 55, is to show that this sum of these cotangents, cotangent A over 2, cotangent B over 2, plus cotangent C over 2, is equal to this parameter S divided by this radius R. Okay, it's actually a lot easier than it looks, though a little bit tedious. Here's how you do it. First, let's focus on this side over here. And if you focus on this side, you see that this length C is made up of this length and this length. This length is the distance from P to F. It's the distance from P to F, and the distance from F to Q. All right, F is just an intermediate point. So the total distance, which is called C, is the distance from P to F plus the distance from F to Q. Okay, now let's focus on this little triangle right here. Angle A is bisected, so this little angle is A over 2. It's got a 2 legs of a right triangle. One leg is R, the other leg is PF. So you can say that the tangent of A over 2 is going to be equal to R all over PF. Okay? Okay, and so likewise, let's do the same thing now looking at this triangle. This triangle is such that the tangent of B over 2 is going to be the opposite over the adjacent, or R all over FQ. Great. So let me do this explicitly, then I'll do the rest a little quicker. So if I look at this relationship, I can move PF up here, tangent down to the bottom. I can rewrite this relationship as PF is equal to R times the cotangent of A over 2. And I can rewrite this relationship as FQ is equal to R cotangent B over 2. And when I add these two things up, I'm going to get C is equal to this guy plus this guy, which is equal to R cotangent A over 2 plus R cotangent B over 2. Well, that's starting to look like what we want here. And in fact, if we just now go side by side, we'll be able to write down a relation. If you look at this triangle, there's nothing special about it. This side is pretty much like this side is pretty much like this side. So I started with side C. If I went to side B here, I'm going to get exactly the same type of relationship, only side A is between angles A and, side C is between angles A and B. This side here, B, is between angles A and C. So I'm going to get this for B through the same considerations. Yep. So I've done this side and this side. Now let me go to side A, and I'm going to get R. I'm between angles B and C. Cotangent B plus R cotangent C over 2. Okay? So let me do this. Let me now add all of these together, and let's just look to see what we're going to get. We're going to get A plus B plus C is equal to, everybody's got an R, okay? There's a cotangent A and a cotangent A cotangent A over 2 and a cotangent A over 2, okay? There's a cotangent B over 2 and a cotangent B over 2 and a cotangent C over 2. So I'm going to pull out that 2, and I'm going to get cotangent A over 2 plus cotangent B over 2 plus cotangent C over 2, okay? I'm going to divide both sides by, yeah, I'm tired of writing this now. I'm going to write it one more time. I'm going to divide both sides by 2 over R. A plus B plus C divided by 2 is S. I'm going to put, that makes an S on the top and R on the bottom, and sure enough, I've got what we were looking for. Tedious problem, but you successfully solved it there by looking at the little right triangles interior to triangle PQR and just using the trigonometric identities on them. Okay, let's move on.